Assalamualaikum and hi to all doctors. We are from Group S and we are going to present chemical kinetics. Chemical kinetics is a study of chemical reactions concerning reaction rates, rearrangement of atoms and formation of intermediates. The rate of reaction is concerned with a decrease in the concentration of reactants or an increase in the concentrations of product per unit of time. It can be expressed as an instantaneous rate at a particular instant of time and an average rate over a large interval of time. In this video, we are going to discuss the rate of a chemical reaction is proportional to the number of collisions between reactant molecules. We are also going to discuss what is collision and effective collisions and what is the requirement needed to increase the collisions to be happen. Other than that, we also discuss the applications of chemical kinetics that we apply in our life.
Assalamualaikum and hi everyone. My name is Siti Nur Syahirah binti Makno. My metric number is 153671. I am going to present theory of chemical kinetics, which is collision. Collision theory states that the rate of a chemical reaction is proportional to the number of collisions between reactant molecules. The more often reactant molecules collide, the more often they react with one another, and the faster the reaction rate. In reality, only a small fraction of the collisions are effective collisions. Effective collisions are those that result in a chemical reaction. In order to produce an effective collision, reactant particles must possess some minimum amount of energy. This energy that used to initiate the reaction is called the activation energy. For every sample of reactant particles, there will be some that possess this amount of energy. The larger the sample, the greater the number of effective collisions, and the faster the rate of reaction. The number of particles possessing enough energy is dependent on the temperature of the reactants. If reactant particles do not possess the required activation energy when they collide, they bounce off each other without reacting. To summarize, the requirement for an effective collision to occur is: first, the reactant must collide with each other. Second, the molecule must have sufficient energy to initiate the reaction, that is called activation energy. Last but not least, the molecule must have the proper orientation.
Good afternoon, my name is Nur Alia Fatihah binti Mufuad with the matrix number 153789. So today I'm going to present one of theory of chemical kinetics, which is transition state theory. In this theory, it says that reactants does not convert directly into products, which means when the reactants collide with each other, they form an activated complex, and also known as transition state. And when it equilibrium with the reactants, it will be very unstable and high in energy than reactants and products. This can be shown by the energy profile diagram. Also, this theory postulates three major factors that determine whether the reaction will occur or not. So the first one is the concentration of the activated complex. The second one is the rate at which the activated complex breaks apart. And also the third one is the mechanism which the activated complex breaks apart, which means that the activated complex can be either converted into products or it will revert back to the reactants. A general elementary reaction A plus BC will form AB plus C with the rate constant K. The reaction pathway from reactants to product passes through a transition state at highest point on the energy profile is shown at the given. The ABC double dagger is the transition state for this reaction. The large K double dagger in blue is the equilibrium constant for the equilibrium forming transition state, while the small K double dagger in red is the rate constant for the formation of the product. Therefore, from the equation 9.28, Kb over H. Kb and H is the constant, which is Kb is the Boltzmann constant, and H is the Planck constant. And the K double dagger can be substituted from the equation delta G standard equals to negative RT ln K. So when substitute, it will become KBT over H times with e power of negative delta G double dagger over RT. And also, the delta G double dagger can be substituted with the equation delta G equals to delta H minus T delta S. And the final equation will be K equals to KBT of H times with E delta S double decker over R times with E power of negative delta H double decker over RT. So this is the equation for transition state theory. When it compared with the Arrhenius equation, the terms in blue is correspond from the transition state theory is corresponds to the EA from the Arrhenius equation, and the terms in red from the transition state theory is corresponds to the A from the Arrhenius equation. Thank you.
Now, let us talk about the application of the chemical kinetic. Here is the chemical kinetic can be applied, especially in the food science, for the prediction of the change in the quality of a food as a function time and environmental condition. The Arrhenius equation expresses the temperature dependence of the rate constant for the elementary chemical reaction. So here we can look, this is the Arrhenius equation, which is we can look this is K is equal to A exponential negative EA over RT, which is R is equal to 8.31, which is this is the constant one. The parameter A is the frequency factor, which is taken as independence of temperature, and the activation energy is equal to EA.
The application of chemical kinetic in food industry is thermal food processing. When the food is processed, the chemical change will take place during the thermal procedure. Thermal food processing is to reduce the enzyme activities in the food to ensure for the better quality. As example, thermal food processing in meat. When the meat is heated around 50 degrees Celsius, the intramolecular bond will be break due to increase in molecular motion, while when the meat is heated during 60 degrees Celsius and 70 degrees Celsius, the connective tissue of meat will shrink, and at the end the meat will be dry. This to ensure the quality of meat.
In conclusion, several factors such as temperature, the concentration of reactants, and catalysts affect the rate of a reaction. We can conclude that the rate of a chemical reaction is proportional to the number of collisions between reactant molecules, and chemical kinetics can always be applied in our life. Along with visibility and accidents, it is critical to understand a chemical reaction's rate and the factors that influence it. For example, what factors influence how quickly food spoils, or what governs the rate at which fuel burns in car engine? All of this can be answered by chemical kinetics. Last but not least, the rate constant is the proportional factor in the rate law. That's all from us. Thank you.